This is part 7 of the Module 11 lecture. In this section, we're going to solve an example, and actually it's the example that we have been working with through this in this section. And in this particular case, is that the student wants to work 16 hours per week or increase his working external workload from 8 hours to 16 hours per week, and this person is worried about how much that will impact his GPA, and we're relying on the information for a random sample of 10 students, and we already adjusted the regression model, and the purpose here is to determine if this slope parameter in the module they were using to explain the behavior of GPA on hours worked per week, if that slope value is non-zero. Or in other words, that we're saying that if it is not zero, then that the GPA depends on the hours worked per week. And we're going to use a significance level of 0.05. All right, so we're going to use our old procedure to test the hypothesis. So we're going to go through the 5 steps. And as we've done before, in the previous sections, we already calculated the average of the y values, the average of the x values. The sum of squares, we already found the estimate of the intercept. We found the estimate of the slope. And we also calculated the standard error of the residuals. All right, so this is the information that we have calculated already. So in step 1, again, we propose the hypothesis, and here we want to test if the actual slope parameter is 0 or is different from 0. So again, given the alternative hypothesis, we know this is a two-tailed test. And from the introduction of the problem, we know that the significance level to use is 0.05. All right, what distribution should be used to perform this test? Well, we are working under the assumption that the random errors for any hours worked per week, of, in other words, for any value of x, are independent, normally distributed with mean 0 and constant population standard deviation, which will be estimated with the standard deviation of the residuals, S sub b, because we don't know what this population standard deviation of the random errors is. So the fact that we are working with a normal distribution and the fact that we are replacing an unknown population standard deviation with a sample standard deviation tells us that we are working with a t-distribution, or that we should work with a t-distribution with n-2 degrees of freedom, or in this particular case, 8 degrees of freedom. So this is the distribution that is applicable for this problem. Notice all the things that I list to justify the use of the t-distribution. So in your exam, your final exam, remember to list all the elements that justify the use of the t-distribution. This is important so you don't lose any points in your final exam. All right, next we calculate the test statistic, and we're working under the assumption that the slope parameter under the null hypothesis is 0. Therefore, we use this form of the test statistic. Now, I put over here the numbers that we already calculated. So here's the estimate of the slope, minus 0.0297. And we have the standard deviation of the residuals, 0.4504, and then we take the square root of the sum of squares of the x's right here. All right, so here's the t observed is minus 2.6162. Then in step 4, if you decide to go with the critical value approach, then you have to go on to table 5, and because it's a two-tailed test, we divide alpha by 2, that's 0.025. And you know we're working with a t-distribution with 8 degrees of freedom. So we go to that row for 8 degrees of freedom on table 5, then look at the top and look at the probability 0.025, and then we come down on that column, and when that intersects the row for 8 degrees of freedom, we find that the upper critical value is 2.306. And we know that by the symmetry of the t-distribution, the lower critical value is minus 2.306. Now notice that I not only list the values that will determine the rejection regions, but I actually say what the rejection regions are. So we have in the left side, any t-value that is less than 2.306 will be in the rejection region, or any t-value larger than 2.306 will be in the rejection region. So please include the rejection region when you solve problems in the exam. All right, so now if we decide to use the p-value approach, again, on table 5, we look at the row for 8 degrees of freedom, and we try to see where this t-observed value is with respect to the values listed there. And then if you look at that row, you will see that this value, the positive value, is between values of 2.306 and 2.896. And this corresponds to the probabilities of 0.025 and 0.01. So since the p-value, because it's a two-tailed test, is 2 times the probability to the right of the positive value, then the positive value of the t-observed, then the p-value is between 2 times 0.025, the upper bound, and 0.025 and 2 times 0.01 or 0.02. So the p-value is between 0.05 and 0.02. If you like to find the exact p-value, you can use Excel, use this formula, and you will find that the exact p-value is 0.0308. All right, so now we know the rejection regions, we know the p-value, then we see that the t-observed is smaller than the lower value, the lower critical value. So we know that the t-observed is in the rejection region. Also, the p-value is lower than 0.05, but higher than 0.02. Then the p-value is smaller than 0.05. So given either situation, we see that we reject the null hypothesis. So the slope is not 0. So the interpretation of rejecting the null hypothesis and the null hypothesis is that at a significance level of 0.05, we can say that the slope parameter is not equal to 0, indicating that the hours worked per week significantly affect the average GPA of students. All right, so this is how we perform the test. Now, what I'd like to show you is how we do this in Excel. In Excel, we need to, if you don't already have this data analysis tool pack installed, you need to install it. I already posted the instructions on Blackboard. Very easy. So follow the instructions, make sure that this is installed. And let me go over to Excel. So if you have this already posted in Excel, then you will have here under this data, if you click there on the very right, you see this data analysis. If you don't have that analysis tool pack installed, you will not see this. So you need to install it in order to see this. All right, if you installed it successfully and you see this and you click on it, and then here you look for the part where it says regression. So there are multiple things that Excel can do, and here is regression right here. So once you find it, click OK, and then to enter the input range for the Y's, you see here's the Y GPA, so you select that and select the title as well, and that gives the range of the Y values. To enter the range of the Y values, click on the next window, and then again click and select from the title to the last data value. Because we click on the title, we need to click on this box that says labels, so that Excel knows that we included the labels. Also click on this confidence level of 95. And then right now we won't do any of the rest. So you just do that part. So you just click OK, and because this new worksheet is selected, the results will appear in a new worksheet. So if you do that, this is the output from Excel. All right, so you can see, I don't think it's very difficult to do. I included the instructions on the slides. And let me switch over to the slides. And you see I put the instructions on the slides. So everything I did is here. And here's the output. So here in the output, then you see that here's the R-square. There are other types of R-squares that are not useful to us for simple regression. So the one that it matters to us is this R-square. Also, this analysis of variance or ANOVA table, in this particular case, is not really relevant because that F-test is the same as the T-test. So we rely on this table over here, the last table. So we're not going to talk about this table. And just notice that the p-value for the ANOVA table is the same as the p-value for the t-test that we perform. All right, so here Excel is showing you the estimate of the intercept, it's showing you the estimate of the slope, then it's showing you the standard error of the residuals, it's showing you the t-statistic or the test statistic, and it's giving you the p-value for the hypothesis that the slope is 0. Again, we're not paying attention to the hypothesis test for the intercept, since it is not very useful for deciding whether or not the x variable affects the y variable. And one thing we didn't talk about, but you know how to interpret the confidence interval. Here's a confidence interval for the slope parameter. So you can say that with a 95% certainty that the value of the slope is between minus 0.05584 and 0.00345. So again, this is what Excel will give you. And it is likely, very likely, that in the exam I will give you this information and ask you questions about it. And so please look at this, make sure you can do it. And in the homework, I know that Pvalue Plus does not ask you to use Excel, but if you rather use Excel to answer the questions, that's fine with me. And that will be good for you because you know how to use Excel much better than perhaps that you already know it. All right, so we're done with that. In the next recording, we'll talk about correlation.